Here you have to use the derivative result. Huh? Suppose, so let I will consider the given function phi of s. Phi of s is 1 upon 2 into log of s minus 1 divided by s plus 1. So further I will write this term as 1 upon 2 into what I will do? I will apply property of logarithm. Just a minute. Huh? That I will write as 1 upon 2 into bracket log of s minus 1 log of s plus 1. Okay. Now differentiating with respect to s, then you will get phi dash of s is equal to 1 upon 2 into bracket derivative of log is 1 upon minus 1 upon derivative of log of s plus 1 is 1 upon. Now both side I will take inverse Laplace transform. Therefore L inverse of phi dash s is given as, what is the right side term? Yes, what is the right side term? What is the derivative of first term? 1 upon 2 constant.
E
That
raised to t.
yes, e raised to t, and second one is e raised to minus t. So I will write this bracket as e raised to t minus e raised to minus t. Can you recall any definition how it can be written as e raised to t minus e raised to minus t divided by 2? It defines some hyperbolic function
Cos hyperbolic.
or sine.
Sine hyperbolic.
It is sine hyperbolic. So it can be written as hyperbolic sine of t. Okay. But we know that the result tell us that L inverse of phi dash s is nothing but minus t into L inverse of phi of s. I think yesterday we have seen this result. Okay. Now in this case, I will substitute the value. L inverse of phi dash is nothing but hyperbolic sine of t. Okay, that I am writing as it is minus t into L inverse of phi of s. काय येणार सांगा? I will write L inverse of, what is your phi of s? 1 upon 2 into log of s minus 1 divided by s plus 1. Or the same thing, I will write L inverse of 1 upon 2 into log of s minus 1 divided by s plus 1. This can be written as minus hyperbolic sine t divided by t, and that is the final answer. Simply by using the derivative result, you are finding that. Okay, any doubt?
No, sir.
Background आवाज येत नाही ना आता?
Little bit.
What happens? We are sharing the lab. Simultaneous parallel lectures are going on. Okay, fine. Next example, we can continue. Fifth one. Again, same result you have to find. Find inverse Laplace transform of. Find inverse Laplace transform of cot inverse of cot inverse of cot inverse of s minus 1. So let I will denote phi of s is equal to cot inverse of, these are the standard examples, so you have to remember. So can I write this cot inverse in terms of tan? In terms of tan inverse, what is the result? I think that result you have studied. Hmm? Tan inverse x plus cot inverse x is equal to 1. Okay, by this result, how we can express cot inverse? I think something, okay, it can be written as a pi by 2 minus, right? It can be written as pi by 2 minus tan inverse of s minus 1. Am I right? If yes, then differentiate with respect to s. Then you will get. What is the differentiation of phi? We denote it as a phi dash. Just a minute, and that because of auto sign, it will become phi dash of s is equal to the outside minus as it is. What is the derivative of tan inverse of x? Yes, I'm corrected now. I'm not using second screen. That's why. Meanwhile, respond me. Okay. So further, it can be written as minus 1 upon s minus 1 bracket square plus 1. So taking inverse Laplace transform, L inverse of phi dash s is given as L inverse of minus 1 upon s minus 1 bracket square plus 1. So this negative sign I will take outside by shifting theorem e to the power t into L inverse of 1 upon L inverse of 1 upon s square plus 1. And what is the inverse Laplace transform for that bracket? Which is minus e to the power t into, this is sine t. Is it right? But
Yes, sir.
we know that in L inverse of phi dash s is minus t into L inverse of phi of s. And in this result, if you substitute the values, then this is minus e to the power t into sine t equal to minus t into L inverse of cot inverse of s minus 1. The same thing we can rearrange the term inverse Laplace transform for cot inverse of s minus 1 is e raised to t upon t into sine t. Correct? Simple examples, I think. These are the simple examples. Now, one example you can try. I will copy this one as it is. Control C, Control V. And suppose this is a next example, sixth one. I will give 2 minutes. Parallel steps you have to follow. Sixth one, you have to complete here only what I written called homework. Suppose this is s plus 1. What is the answer? Take 2 minutes. I will take the notes of the next units. Meanwhile, Done? Completed? This is almost end for the Laplace. Last point is remaining. Now see, once again I will go to the syllabus. I think the last one is solution of this part is remaining. Solution of this part is remaining. That I will continue. Okay. Hello. Okay, completed na? 28 students are there. Now the next part. Application to linear differential equation with constant coefficient. You have studied the method that is first unit how to solve a linear differential equation with constant coefficient. The same equations you have to solve by using that Laplace and inverse Laplace transform. Okay, I think all of you are with me now. Okay, let us continue. So consider the differential equation. Consider the differential equation. I will take a particular second order only. A d2y by dt square, A d2y by dt square plus B dy by dt plus c into y is equal to some function of t. In the first unit, the dependent variable may be x. Okay. In this case, the independent variable is t, where a, b, and c are constants. These are the constants. Y is the dependent variable, t is the independent variable. So here we can use Laplace and inverse as an operator to find the solution. So taking Laplace transform on both sides. Taking Laplace transform on both sides. Okay. Means first, by linearity property, I will write L into A d2y by dt square, or we can write that A outside directly. So this A is a constant. That's why I will write outside also. Is it right now? A plus B into Laplace transform of dy by dt plus C into Laplace transform of y is equal to Laplace transform of f of t. Okay. Now consider, I will use the notation Laplace transform of y. I will denote as y bar, and it is a function of s. And Laplace transform of f of t is f of s. I am assuming. Can anyone recall? Can anyone recall what is the derivative of Laplace transform of f raised to n? F raised to n. N means nth derivative of t. Yes. Can you refer your notes? Can you refer your notes? Laplace transform of nth order derivative. Pradnya, can you tell? Pradnya?
Sir, n minus 1 factorial
No, 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 no.
upon
Laplace ट्रान्सफॉर्म आपल्याला रेफर करायचा आहे. Laplace, not inverse.
1 upon
Mhm, mhm. Yes, anyone? Yes, anyone? Refer your notes, na. You have studied Laplace transform.
Gamma n plus 1.
No, 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 no. These are the notations, okay? For this notation, I am assuming that Laplace transform of f of s is equal to f of t is equal to f of s. So, nth order derivative of Laplace transform, you refer that result. Anyone, Afia? She may not be in the meeting. Sakshi?
N
Yes, sir.
factorial
Huh?
upon n plus 1.
Yes, yes.
N factorial upon n
n
plus 1.
factorial
Huh.
N factorial upon n plus 1.
N factorial upon n plus 1.
n factorial upon yes raised to n plus 1.
हा हा जो n आहे ना जरा बाळांनो लक्ष द्या दिस इज नथिंग बट द डेरिव्हेटिव्ह यू हॅव टू रेफर द डेरिव्हेटिव्ह Laplace transform of derivative nth derivative it is not a power, it is not a t raised to n, f of t raised to n derivative result. I think I will write, you verify at least. It can be written as s raised to n into f of s, s raised to n into f of s minus s raised to n minus 1 into f of 0, value of the function at 0, minus s raised to n minus 2 into value of the derivative at 0, minus continue up to n minus 1th derivative of the given function at 0. आठवते हे रिझल्ट शिकल्यासारखं? Say yes or no at least. Huh? I think this result you have studied, na? Laplace
Yes, sir.
transform of derivative. Very good. Okay, next. Suppose this result, if you are applying for the second order derivative, then it can be written outside bracket a is constant, that remains same. Okay, outside bracket that a is a constant, that remains same. For the second order derivative, what is the n in this case? In this case, the value of n is 2. Value of n is 2. So that's why you have to start with s square. S square into Laplace transform of y, that we are denoting as a y bar, minus in each step you have to reduce the power of s by 1, it becomes s, and value of the function at 0 minus s raised to 0 is 1, and you have to increase the order of derivative y dash at 0. Understood how I am writing this? Is it clear?
Sir, can you repeat it one more time?
Now see, I will use the highlighter. What is the value of n in this case? Yes, you have to reply. Someone should reply. What is the value of n means कितवा derivative काढताय तुम्ही? Second order.
2.
Value of n is 2. So that's why you have to start with s raised to 2. Right? You have to start with s raised to 2. Now next you have to multiply it by f bar of s, means f of t, its Laplace transform f of s means f bar f of s. But you are taking derivative of y, and derivative of y or Laplace transform of y we are denoting as a y bar of s. So that's why here it will come as a y bar. So the next step after this, if this is s raised to n, each step you have to reduce the power of s by 1. If you were started with s square, then you have to reduce the power of s, then it will come as a s raised to 1. And what happen? This function f of t means कोणाचा डेरिव्हेटिव्ह तुम्ही काढता तो फंक्शन ॲट 0. आता तुम्ही कोणाचा डेरिव्हेटिव्ह काढता y. So value of the function y at 0. So again, you have to reduce the power of s by 1. That becomes s raised to 0. Anything raised to 0 is 1. And next, you have to take derivative of this term. So you have to increase the derivative. आता तुम्ही एकच डेरिव्हेटिव्ह येतो 1. समजा जर पुढचा टर्म लिहिणार असाल कॉन्स्टंट 1 चा टर्म काय इथं संपलेलंच आहे ना आता. म्हणजे इथपर्यंत आपण अप्रोच झालेलाच आहे. Means you have to continue the term still you are getting a s raised to 0. Is it clear?
Yes, sir.
Next, can anyone tell me it is a Laplace transform for second term? Yes, I will write plus b as it is. Yes. Namrata, Laplace transform of dy by dt. First order derivative you are taking. No. Ishika? Ishika Jadhav? No. Aishwarya? Ritesh?
Sir, sy0 minus y.
हा हा हे बघा आता डेरिव्हेटिव्ह कुठला ऑर्डर आहे आता व्हॉट इज द ऑर्डर ऑफ द डेरिव्हेटिव्ह इन दिस केस यू हॅव टू रिप्लाय ना व्हॉट इज द ऑर्डर
1.
1 means s raised to 1 you will get right na that I will write yes. Is it okay? You have to reply.
Yes, sir.
S raised to 0 multiplied by Laplace transform of y, and that we are denoting as a y bar of s. Where I written? Here, Laplace transform of y. Okay. Now the next onwards minus. Next onwards minus. You have to reduce the power of s by 1. Then it will come as a. 1. Okay. 1 and value of the function at 0. Value of the function at 0. Now next possibility is not there. That's why you have to close this. Is it okay? Plus
Yes, sir.
c into. Now here only you are having y. Laplace transform of y we are denoting as a y bar of s. And Laplace transform of f of t we are denoting as a f bar of s. Okay. Now after this what happens, you have to convert this equation to some y bar of s equal to some function of s and apply inverse Laplace transform to find the solution. Okay, the required solution is obtained by taking inverse Laplace transform, transform of y bar of s. Okay, I will take one example, you will get more clear idea. Suppose the first example, and this is the end and this is the last point. Solve by using Laplace transform method. Laplace transform. The equation is d2y by dt square plus dy by dt equal to 2 with initial condition. It is given that y of 0 is equal to 3 and y dash of 0 is equal to 1. Okay. Now, one example you initially listen carefully. After this example, I will stop and I think one more lecture we are in. That also I will take on this same method and that is the end. And if you are having doubt, immediately ask because I think question paper nature I discuss with you. Yes, na?
No, sir.
No.
Yes, sir.
I think discussed during
Yes,
the study. That's why weightage for the
yes,
last
sir.
2 units is more. That's why listen carefully. Okay. Okay. Now, first I will write the given equation. What is the given differential equation? It is d2y by dt square plus dy by dt equal to 2. Okay. Suppose this I will write as a number 1. Also, the initial conditions are given. Also, it is given that y of 0 is equal to 3 and y dash of 0 is equal to 1. So let Laplace transform of y we are denoting as y bar of s or y bar. Therefore, taking Laplace transform, taking Laplace transform on both side, on both side of equation 1. Then what we will get? First step I will write as it is. Okay. So by linearity property, this is Laplace transform of d2y by dt square plus Laplace transform of dy by dt equal to Laplace transform of 2. Okay, by linearity property. Now, can anyone tell what is Laplace transform for the first? Hmm. That result you have to use. What is the result? If required, that I will copy. This result you have to use everywhere. Control C, Control V. So this result you have to use. This is for your reference. So Smith, can you tell what is the order of the derivative? What is the order of the derivative? 2.
2,
That,
sir.
that means you have to start with s square, right? Na? S square into y bar of s. Next, s raised to 1. You have to reduce the power of s. And here you have to take y of 0 minus y dash of 0. So this is Laplace transform for the first term. Is it clear? Plus Shravani, can you tell what is Laplace transform of dy by dt now? Shravani.
Yes, sir. S power 1
Hmm. Good. Y
d
bar. First, always
y
Y bar.
bar
Y bar. Huh?
minus
I will write wait.
mm,
S power 1 means S into Y bar of S minus.
minus 1 into y of 0.
Yes, very good. 1 not necessary to write directly Y of 0. So this is end for the second one. And what is the Laplace transform of 2? Okay, anyone who is not active? Ankita? Ankita?
Yes, sir.
Laplace transform of 2. Means 2 you can take out,
2
right?
into
2
2
we
into
can,
1 by s.
yes, 2 into 1 by s. I think, is it clear? Anyone is in the class who is not understood this step, please write in the chat box. Let us check. If not understood, then write. So I'm taking pause, whether you are understood or not, that I have to take the review. I think everyone is understood, right? Na? Right, yes. Those who are understood. Right, yes. Okay. Namrata say yes. Okay. Majority students, they are saying that yes, that means they are understood. Okay, fine. Thank you. I will shift to the next. So what I will do, I will collect the term of y bar s or first step s square y bar of s as it is minus s. Now see, in the statement it is given that y bar of 0 is equal to 3. Okay. In the statement it is given that y bar of 0, I will highlight that term. This term you have to replace as a 3. Okay. And y dash at 0, जेवढं लागणार आहे तेवढं तुम्हाला दिलेलं असतो. Y dash at 0, that is given as a 1. So that value I will substitute. S into 3 minus 1 plus S into y bar of S minus 3 equal to 2 by S. I think here simply we are simplifying the steps by substituting the particular value. So next one, I will collect similar terms together. So y bar of S, y bar of S, these two terms I will take together. And from that, y bar of S I will take common. Then remaining is S square plus S equal to 2 by S. All remaining term I will transfer to the right side term. There is a single term which is a minus 3s, and when you are right to the right side, that become plus 3s. Now after that, if you consider the constant term minus 1 and minus 3, that become minus 4, and that you have to write to the right side, that is plus 4. Is it right? Or the same equation I will write y bar of s, or simply you can write y bar also. In bracket, I am writing that s means it is a function of s, and from second bracket I will take s as a common. Okay, so I will take s into s plus 1 equal to 2 upon s plus 3s plus 4. So from this, what I will write, y bar of s is equal to, I will multiply the whole equation by 1 upon s into s plus 1 by this term. Then what happens? This term get cancelled. So here I will get 2 upon s square into s plus 1. Am I right? Plus 3s plus 4 upon s into s plus 1. Check whether I'm correct or not. Okay, hope so. My steps are correct. Taking inverse Laplace transform. Taking inverse Laplace transform on both sides. On both sides, then you will get L inverse of y bar of s is equal to, I will use linearity, 2 times L inverse of 1 upon s square into s plus 1 plus L inverse of 3s plus 4 divided by s into s plus 1. Suppose I think equation 1 and 2, that number I am using, this I will call as a 4. Up to this, any doubt? Up to this, any doubt?
No, sir.
Okay, fine. I will continue. Now, you have studied method to find inverse Laplace transform. So, I will make two parts here. Okay. Suppose the first one, I will use partial fraction method to find the inverse Laplace transform. So, here 1 upon s square into s plus 1 can be written as, so s square is repeated, that's why a naught upon s square plus a1 upon s plus some constant b upon s plus 1. Can anyone recall what is the formula for an minus 1? For your understanding, I will write here. a n minus 1 is given by 1 upon n minus 1 factorial into n minus 1th derivative of n1 of s, and value of this function at s is equal to, guess anyone? At s is equal to, what is the point? Zero, na? And in this case, n1 of s, who will tell? Who will tell? In this case, what is n1 of s? Aishwarya, what is n1 of s?
1 upon s plus 1.
Already I written. Okay, you have to read that. Now, where? Now, these are for your understanding. These references are written here. Okay. Now, where the constants are given by a naught is given by 1 upon 0 factorial into 0th derivative. Okay. n1 of s is nothing but 1 upon s plus 1, and value of this function at s equal to 0. So this becomes simply 1 upon at s equal to 0. So this implies a naught is equal to 1. Is it right? You have to put s is equal to 0. Next, a1 is given by 1 upon 1 factorial into first order derivative, because in the formula I am putting n is equal to 1. In the formula I am putting n is equal to 2, first order derivative for 1 upon s plus 1. After derivative, or to put s equal to 0. That is 1 upon 1 factorial is 1, and derivative, what is the derivative of 1 upon s plus 1? What is the derivative of 1 upon s plus 1? What is the derivative of 1 upon s plus 1? What is the derivative of 1 upon s plus 1? Next step also written. It is of the form 1 upon x, so derivative is minus 1 upon x square, and put s equal to 0. It becomes minus 1. And next, b, for b, it is a linear and non-repeated, which is 1 upon s square, and value of this function at s equal to minus 1. Am I right? That is, value of b is 1. Check the calculations. Check the calculations. Therefore, L inverse of 1 upon s square divided by s square plus 1 is given as L inverse of, I will substitute the value. A naught is 1, 1 upon s square, plus A1 is minus 1, 1 upon s, plus B is 1, and which is 1 upon s plus 1. And this one is given by, what is the inverse Laplace transform of 1 upon s square? Linearity property also I am using. Minus, what is the inverse Laplace transform of 1 upon s? Plus e to the power minus t. Suppose this is next number 4. Okay. So what I did, I calculated inverse Laplace transform for the first one. So in the same manner, second also you can complete, na? In the same manner, second also 3s plus 4 divided by s into s plus 1. So both are non-repeated. I will write a upon s plus b upon s plus 1, where this a is given by 3s plus 4 divided by s plus 1, and value of the function at s is equal to 0. And if you substitute, calculate a. and tell me. Yes, anyone? Are you with me? I will write the formula and try to complete you. In the same manner that B is given by. So calculate that. Anyone can tell the constants. What is A? If you substitute S is equal to 0, it comes as a 4. And second B,
-1.
-1.
1. Okay. B is -1. Therefore, therefore, L inverse of 3s plus 4. काय आलं? Hello. Okay, 3s plus 4 upon s into s plus 1 is given as L inverse of 4 upon s minus 1 upon s plus 1. So which is given as, what is the inverse Laplace transform? First term, if you use the linearity property, 4 minus e to the power minus t. Okay. Suppose this is fifth one. This is a fifth one. And one more thing, what is L inverse of y? Our aim is to find the solution y, and which is given as 2 into t minus 1 plus e to the power minus t plus 4 into e to the power minus t. And if you simplify this, this can be written as 2t minus 2 plus 2 times e to the power minus t plus 4 into, okay, what is the term? 4 into e to the power minus t, which is given by 2. Constant term is 2 plus 2t plus 2t plus e to the power minus t. So that is the solution. Okay. So just look at this and see. Okay, that is the solution. I will take 45 minutes. Okay.